Okay, this video is about ionization energy. So remember that ionization energy is the energy required to remove an electron from an atom. So I would draw the half shell models to help me figure this out. So starting off with sodium, I look and sodium has 11 protons, so 11 positive charges for sodium. And sodium has 1, 2, 3 shells. 1, 2, 3 shells of electrons. Okay? Magnesium, it has 12 protons, and it also has 1, 2, 3 shells. Okay, chlorine. Chlorine has 17 protons, and it has 1, 2, 3 shells. 2, 3 shells. And then francium, that's over on here. I'm going to put it over here because it's in group 1A. It has 87 protons, but francium has 1, 2, 3, 4, 5, 6, 7 shells of electrons. 1, 2, 3, 4, 5, 6, 7. Okay, now remember with the ionization energy, the first ionization energy, they're trying to take an electron from the, normally they always start with the furthest shell out to remove an electron. Okay? Now, in general, with ionization energy, the further the electron is from the nucleus, the more or the less energy that it's going to take. So right away, I can see that this francium has an electron that's way far away from the nucleus. So it's going to take the least amount of energy. So I'm going to say that's number 1. It's going to be the lowest. Okay, so we could say FR has the lowest ionization energy. I'm just going to abbreviate that. IE has the, oops, I didn't write the lowest ionization energy because it has more shells and more shielding. The shielding effect will offset the number of protons in the nucleus. Okay? Basically, the further away an electron is, okay, it's going to take less energy to remove it. Okay, because the nucleus can't attract it that well. Okay? The electron is further away. Okay, now, so we know that that's the least because it has more shells, more shielding. But now these all have 3 shells. So we have to look at, when they all have the same number of shells, you have to look at how strong the nucleus is. So sodium has 11 protons holding this electron. Magnesium, or 11 protons holding the electron. Magnesium has 12 and chlorine has 17. Okay, 17 holding the electron is going to make the ionization energy greater. So that's going to be number 4. This will be 3. This will be number 2. Okay, so these all have 3 shells, but chlorine has more protons than magnesium and sodium. Okay? So chlorine has a greater ionization energy than magnesium, and magnesium has a greater ionization energy than sodium because all have the same number of shells, which means the shielding is exactly the same. See, all have the same number of shells, but the atoms with more protons have a greater ionization energy. So chlorine has more protons. They all have the same shells, but chlorine has more protons, so it's going to have a greater ionization energy than magnesium. And magnesium is going to have a greater ionization energy than sodium because it has more protons holding onto the electron. So to remove the electron, when things have the same number of shells, more protons means a greater ionization energy when things have the same number of shells. Okay, that's it for this video.